this is really the motto of Lambda. You write the code, and the cloud takes care of instances. You're no longer in the business of counting machines and scaling up and scaling down, or writing software or using Amazon software to handle that for you, to auto-scale up and down. How many people have ever run an Amazon autoscaler or Google or anything like that? So again, a few people. It's not hard. I mean, they actually do a pretty good job of it, but it's another layer of management. It's another service you have to get used to. See? So just to reiterate, there's no need to allocate instances. You're not scaling them. You're not doing health checks on the instances because you don't even know where they are. You have as many parallel ones running as you need. Scales up, scales down automatically. You have a nice predictable cost model. Now there's an asterisk that I'll get to at the end here that can catch you. But in general, you know how many instances, if you know how many calls, you're going to get or you expect to get in a given month, and you've bounded the total amount of work, and you're only charged for the CPU time that it's going to use. That's the cost model that Amazon has. You can estimate in advance what your costs are going to be. You send, when you have a new version, you deploy it out to Lambda, and again, the actual mapping of that code to all of the machines out there on which it's running, handled for you automatically. And finally, just by adopting this model, it encourages a microservices design to your application. The notion of breaking this large conceptual thing into very small chunks, which feed into each other, a kind of data flow model, communicating through streams of one sort or another, or writing to storage. Most often something like DynamoDB, a NoSQL database. I imagine you could write to Amazon's relational products as well, although I don't see many applications doing that. So this isn't a model that works for every application. It's certainly not something you want. You probably can't do halfway measures with it. If you have an existing thing that you're migrating to the cloud, well, this isn't going to help you in that context. But for a greenfield application where you're starting off from scratch and you really just want to focus on your code and get out of the business of managing instances, it's an excellent solution. So let's start with an example. Your first Lambda, make the font big enough and you get the dreaded code wrap. Okay, you're all programmers, you can handle this. So here it is, a hello Lambda in Python. This is actually, except for the comments that I added, this is one of the, this is a template that Amazon provides for you when you actually start to play around with Lambda. There is a free tier, so if you have an account on that, well, if you don't already, you will with the coupon you've been given here. You can sign on and try this out for yourself, and it won't even charge against your credit for a simple playing around with. So how many people here, Python at least, read Python? So about half. Okay. I'm hoping that it's simple enough that even if you're not familiar with the specifics of the language, it's straightforward. So here we're just naming a library we're going to use. At the beginning of the function, or at the beginning of the file, we write a bunch of startup code, and talk more about that later. In this specific simple case, my startup code is simply printing out that I'm doing a startup, loading function, and then we have a single function, or at least a top-level function, if we call others, that's executed once per event. And so it's called Lambda handler in this case. That's a very common name. And it takes two parameters, an event and a context. The event is simply information about the event that prompted the call to the function, and the context is information about, it contains descriptions of the specific context of the call. I'll give a little more details lower on down on the screen. So anyways, the function is called. Then it does whatever it needs to do. In this case, it's a fairly straightforward, well, actually trivial, nonsensical thing. It just prints a bunch of values. The event, depending upon the language, there are several supported languages, but whichever language you're using, the event is a dictionary type or a map type or whatever it's called in the language you're using. key value mapping. So we're just, in this case, the event has only 3 keys called key 1, key 2, key 3, and we're just printing their values. That's the total extent of our function. In any print statement in Python and their counterparts in the other languages simply goes to the Amazon log. So all we're doing here is writing up the values into the log. We could, and presumably for a real function, we would want to write to storage like DynamoDB or put something on a queue. We want to do something useful in the world rather than just consume our log files. Having done whatever our processing is, we have a choice. We can either return successfully or we can return as an error. In the case of Python, a successful return is just indicated by a return from the top level function. So we're just returning, in this case, the string which is associated with the key 1 in the event that we're passed. This, again, is a little contrived. I needed to be able to create events that forced a failure. If the event does not have an OK key, then we take the else clause, and in that case, we raise an exception. And this should be part of the comment. Just got wrapped around. If you raise an exception in Python, that is treated as a failure in the Lambda model. So you either succeed or you fail. Other languages that you can use under Lambda have slightly different ways of representing this, but the model is the same. You end with a success or a failure. Questions about that? So you get an event, you do your processing, call your services, and you end either with a success or a failure. Okay, let's go in. So here's let us hope that my network is still working. Actually, let's expand that a little just for legibility. So this is actual live on the Lambda function. Actually, just to give you a sense, because people may not have ever had to, oh, here we go. I said that Amazon has a lot of services beyond virtual machines. I mean, it has, I'm not expecting to be able to read all that stuff, but that's how small the screen has to be to list all the currently available services in the Oregon West region. And this is representative of all of their regions. I tried counting it. I probably missed 1 or 2. It's over 50. Many of them are highly specialized, so you certainly won't use them all in any given application. And some of them are more focused on managing instances, so things like this region up here, building virtual machines, a bunch of networking stuff down here. But in general, there's a huge number of services you can be calling. And one of the great things about Lambda is that it allows you to take several services, pipe them together with a simple function, take the result of one service, pipe it into a second one. It's great for plumbing things together, writing simple applications that connect stuff up. So we're going to focus here on Lambda for the moment. This is the Lambda console. If you were doing serious development, you probably would not be going through the console. There's typically testing on virtual machines and then uploading through the API that Amazon provides with their command line interface. But for demonstration purposes and playing around, the console is perfectly fine. So let's create a Lambda function. They have a bunch of templates here. I guess I should say currently Lambda support, you can write code in Lambda in Java 8, in Node 0.1 if you're a masochist, or maybe your libraries are that old, Node 4.3 or Python 2.7. So it's somewhat restrictive in their runtime environment. We're going to skip the templates because we've got our own code. Defining it is straight. Yeah, it's really blurry. Maybe if I make it bigger. If I can't read it. It's still kind of blurry. Could someone adjust the? Oh, well, let's not mess with it. Is it readable back row? Okay. We won't be able to see the beauty of the whole screen. We'll have to scroll a bit. We'll give it a nice descriptive name. So a name, description can be anything. Here's your options. As I said, currently only three languages and only 4 runtimes. And then, again, you wouldn't do this for a large-scale application, but it's perfectly feasible for us. We're just going to copy this baby. I don't know what the wraparound's going to do. That would be interesting. Paste it in there. We have to, if we define it, this default name, call it Lambda. Where's my? There we go. This is if you call it the default name, then this default entry point will work for you. You need to specify one of the fun things about working with AWS is the elaborate security model, which has all these different roles and permissions and policies. In truth, it's obviously necessary on something like a cloud-based system where anyone, anywhere in the world could potentially call your API. So you need to have good controls, both externally and internally within your organization. When you're just playing around, it becomes unbearably tedious. However, Amazon has done a good job for people just experimenting. They created this simple role called Lambda Basic Execution. You have to do a little bit to define it. Basically, for testing purposes, you define this role, give it all your privileges, make it yourself. The function executes with all of your authority. So that's fine for testing. You specify one of the machine sizes. So all you get to pick is the amount of memory the machine is going to have, and there's 14 different memory sizes from 128 meg to 1.5 gig. They scale the CPU size accordingly. So when you pick your memory size, you're picking, in some not entirely specified way, the size of the processor. And then you say, here's the maximum amount of time I'm going to permit a given event to require. If you have a virtual private, I never remember the C, virtual private network, except it's not cloud, thank you. Virtual private cloud for security purposes, you can run Lambda within that. I'm not going to bother with that right now because I'm just going to build a public function. Review screen, yes, everything's good. Okay, we have defined it. Now, we need to, first thing we want to do before we make it callable by the world is just test that our function works. We're not going to do anything elaborate. To run the test, first we have to define the event we're going to pass to the function as a test. It just so happens that their default, it's a JSON in this case, event. Their default template actually matches the hello world function, except I needed to add one more key. So we're going to send this event with 4 keys to the function. And let's save it and test it. And hot dog. Execution results succeeded. There it is. Succeed. The result was returned was value 1, which is the value associated with key 1. And then there's a long list of events that only an Amazon DevOps person would love. And here we have a summary of what was put to the log. Every invocation has a start, an end, and a report. The report tells you how much time was taken. You are billed for every 100 millisecond increments. We're well under that. Unfortunately, we're being billed for 100 milliseconds, and we used 400 microseconds, so we're actually getting overbuilt here. The size of the memory. So we had a 128 meg instance, which is the smallest we could ask for, and we only use 30 of that. So our simple hello world is actually over-provisioned by the system. And if you want, you can click on that. This is Amazon's logging system, which it has its strengths and weaknesses. It's designed for high volume applications running in multiple regions and so forth. For simple testing, it's a little awkward at times. But you can see essentially what we were shown in the on the screen is what we're seeing here. Here's the value of the log. Note one difference, and I'm not sure why they do this, and this will become significant later. Almost identical, but not quite. So the log output they provide in this screen starts with the invocation of the function and its end, and then summarizes the actual resources used. If you go to the actual log, yeah, you get the start, you get the values that were printed in. So all of these are the same, but you also get whatever was printed out during the startup of the instance. I'm not sure why they don't give that to you in the other screen, but that's where you have to go to find out if anything happened when the instance was started up. Okay, so let's see, can we fit? So the example, you start with the startup code. In this case, it's rather minor, trivial, but for serious applications, you could be loading libraries that you need to run with beyond the standard ones that are provided. So in the case of Java, they only give you the Java runtime environment, no specific libraries. If you're running Node, they give you ImageMagick and a few other things. If you're running Python, you simply get Python standard libraries. So those are pretty basic in every case. Typically, you will have your own application libraries that you'll have to load. And loading them will be done at your dime. That consumes resources. You may want to initialize globals. You might have to open temporary files if you're going to be writing that. You might want to connect the services, open a stream, connect to a database, something like that. So all that is done when the container is started up. Again, I'll return to this at the end of the talk. So in this case, it's just that simple print statement. Then you have code that's called every event, not just when the container is started. And it's passed an event parameter, as I mentioned, and that just provides the details of events. It's a dictionary or a map or whatever that counterpart is in your respective language. The specific keys provided by the event will depend upon the event type. There's a bunch of event types that can trigger, you can set to trigger your Lambda function. And then the context parameter is not as useful. It allows you to query things like how many milliseconds do I have left before I time out? And then it has instance fields that give you things like the request ID that Amazon has assigned the incoming request. You can ask what your log stream name is. You can find out how big an instance you're running in. That's not as commonly useful, but if you need it, it's there for you. And then finally, the function either succeeds or fails after it's done whatever other mutations it needs to do to storage or strings or so forth. Now, functions can be invoked either asynchronously. So am I still, when I walk over there, am I in the, I'm probably vanishing. Yeah, okay, I'll be good. You can invoke you can set the functions to be invoked asynchronously, so that means the event occurs, the function fires, no one's waiting for the result. Presumably, it's writing something to a stream or to the database, otherwise there'd be no point to running it. and the result returned by the function, or even whether the function succeeded or failed, is irrelevant. It's saved in the log file, so you can find out later if you want to do a post-mortem. But as far as the functioning of that call, the result is of no consequence, or the success is of no consequence. You can also have functions in both synchronous. And by the way, initially, asynchronous Lambda was the whole game. More recently, Amazon has added synchronous functions, the capacity to call a Lambda function, wait for the result, and do something with the result that was returned, assuming it was successful. And this is most useful when you're writing an app that's called either by a REST API or called directly by a mobile app. And they support calls from Android or iOS. They have toolkits that work in those environments. And of course, synchronous functions, in addition to returning a result to their caller, they're also welcome to update a database or append something to a stream or something like that. There's no restrictions on them. So they're a little more general. Now, so the event fires, your function's called, it does something, it returns. Again, you don't need to know or care how many machines are out there waiting to run those functions, or how many you need to provision or anything like that. You can set your function to be called by any number of events. It's nowhere near as many, it's not like every service, every one of those 54 services Amazon provides can be plugged into Lambda. For many, it doesn't make sense. They don't necessarily generate events. But there is a wide range of useful services that can invoke a Lambda function. So for example, Simple Notification System, SNS, that's a service that Amazon provides your app can call at and say, send this notification to a wide variety of output formats. That can trigger a Lambda event. You can also get a message from an object through their Internet of Things service. So if you're doing home automation or something like that, or industrial automation, you can plug a Lambda function into that. Amazon's object-oriented storage service, Simple Storage Service S3, when an object is added or deleted to that, you can have a Lambda event that's fired. When someone appends to a Kinesis stream, which is Amazon's stream-based system, you can have a Lambda event fire on that. Now you can also, for a lot of these stream things, you can do it, you can block it so that after 10 appends or something like that, your function is called. When an update is done to Amazon's NoSQL database, DynamoDB, and it's a two-phase thing. The update produces a stream event, and then your Lambda function can be reading from that stream and invoked as a certain number of entries have been added to the stream. When someone appends to a CloudWatch log, so CloudWatch again is the generalized logging system that Amazon provides for you. You can have regularly scheduled calls to Lambda through CloudWatch again, so you can just say, like a cron job, every 5 minutes, fire this function. Or you can call the function directly from Android or iOS, mobile app, or you can call it from a REST API. So these last two are perhaps the most interesting, because now you can build a whole app. You can build your back end, and you can set it up so that it's called either from mobile devices, mobile apps, or it's callable through REST either from a web page or from another service. So I want to talk next about building a REST interface using the API gateway, but first, are there questions or comments or thoughts about the basics of this thing? Yes?
Well, how much control we have of, you said don't care how many instances get created or where they run, but how much control we have all the geographical redundancy and...
Okay, so the question is, how much control do you have over geography? That's a good question. A given a single Lambda function is actually specific to a region. So when you deploy it, it goes out, you have to say this is going to US West 2 or US East 1 or Europe 5 or whatever. Which means if you really want a global service, there is an extra level of effort you go through where you have to say, whenever I deploy to my home thing, say US West 2, then you have some other infrastructure at work that also deploys that identical code, but technically distinct Lambda functions to whatever other regions you want to run in. So you can control by region, and that's the granularity. No finer than that. And unfortunately, you can't say just publish this on every Amazon region because for whatever reasons they don't let you do that. You have to write code that actually floods it out through the regions. If the service isn't available in every one of the Amazon regions, but geographically the regions for which it's available cover the globe.
And when it runs on that one region, is that one data center?
So the question is, does it run in a single data center? I'm going to infer they're coy, at least in the documentation I've seen about that. I'm going to infer in the documentation for Kinesis, they're clear that Kinesis within a region runs on multiple data centers for exactly that point, that if an asteroid or zombie incursion takes down a data center, it doesn't take down the service. And in general, this is how Amazon tries to design their services, so I would assume, but it is in my case an assumption, the Lambda works the same way. When you say deploy to region US West 2, that function is running in multiple data centers as necessary. And if a single center goes down, your service should still run, although it might be a little slower because there's less capacity in the region. There was a hand over there, and then I'll come back to you. Yeah.
Say I migrated from traditional web app to Lambda, and I already have all my authentication and authorization infrastructure in place. Now, my concern is that now I will have to use all this complicated Amazon roles infrastructure and all of that, which means, well, I have to get some peripheral knowledge. That's one thing. And another thing that migrating out of Lambda someday will be much harder.
Yeah.
So
there's two questions there. Both of them are really important. The first is, I have a web app, I have my own authorization. Oh, please, Jeff Bezos, please don't force me to adopt your own authorization mechanisms. So I think the short answer is you don't have to. If you are using OAuth, for example, or no, that's more web-based.
okay, for example, I just store user ID in the cookie.
Okay, so you store user ID in the cookie. So Amazon's own security thing, for the most part, is internally focused. That is to say, all these roles and permissions that they set up are there to allow you to control which IDs internally, which Amazon IDs call a service, and which services can call other services and things like that. So I would argue it's more strongly focused on the internals of the architecture, and so someone in the accounting department can use certain services, but a role in, say, the manufacturing department can only use other services, things like that. And that's why it's complicated, because it's at a very fine granularity. You can say, this role can write only to this table. This role has administrative privileges for all of our tables and things like that. When it comes to external authentication, people there are some services that Amazon provides. I've never used them. But they also acknowledge that people have their own way of doing things, and they support that as well. So it would be more, you'd continue to use whatever your security mechanism is in terms of external authentication, but then internally, which services can do what to what tables and when, you would presumably adopt a finer level of granularity, so that in the event that someone finds a way to call that service, they're on a need-to-know basis, things like that. So I'm not that, I know that OAuth, for example, is directly supported. Well, OAuth is supported by the Gateway API that I'll talk about in a moment. So essentially you can keep your own authorization. It's the internal stuff where you start to add all these roles and permissions and so forth. If you want, you can export that. That's one option you have, to where those IDs, might be a little, in principle at least, you can export the Amazon permissions if you wish, or the roles to certain individuals. But that's more of an internal thing, I would say. You had your hand first, no?
Can you interface with third-party software, in particular MongoDB or LibreOffice?
Can you interface with third-party software? Yes. So you can, what I showed is the most basic thing where you write one or more Lambda functions or Python functions or Node or whatever, and you just run that. You actually can package a whole zip file, and of course, you can call other libraries. So you can build libraries, package them up, import the interface into whatever your language is, JavaScript, Python, Java, and then call it. You can even fire up actual virtual machines. That's other instances, other containers, and run other processes. And now you're sort of, I would say you're deviating from the philosophy, but if that's, you do what you have to do, kind of thing. You could certainly make MongoDB calls from inside a Lambda function. You just need to import the library and run.
But you couldn't host MongoDB within Lambda.
So the question is, could you host MongoDB within Lambda? I actually think that's a kind of category error. You'd probably have virtual machines and load balancers and autoscalers for your MongoDB servers or server, and then your Lambda functions would call that through the client API. That's probably a better organization. So your ops staff is still in the business of managing servers for your database option, whichever one you pick. And at that point, you're just running on Linux virtual machines for the servers. It's the client side that the Java, or that the Lambda will come in. Let me just check the time. Okay, yeah.
How much control do you have over container startup? Because it's something you'd want to minimize.
So the question is, how much control do you have over container startup? I'm going to come to that at the end. So, because there's some other things. Well, it's the end of the talk, so I'll come back to that. Yeah.
So for your demo, you used like a code-based from an X file, right? What other ways are there to deploy code?
So the question is, what other ways are there to deploy code? There's three things. You can just do it at the console, and that's obviously for very small functions where you're playing around. You can submit zip files through the API, or you can tell Lambda to load from an S3 object. So you can put your code up to S3 and then say Lambda, get a function from that. So it's not completely general, but it covers enough use cases. And last question.
So you have a list of events. Could you outline what we can do with result of calculation? So result is global data, right? I can store it, of course, on DynamoDB. I can return it through the REST API if it's small enough. What other options?
So the question is, what are the options I can do with the results? I think I want to distinguish. So within the body of the code, you can make whatever calls you want. So you can, any service you can reach as a client, you can invoke it. And that's probably the predominant outcome, is you're calling us one of the services that your app needs and initiating some effects out there. Honestly, the actual result that's returned, in some ways is very kludgy. If I'm feeling courageous, and I'm not sure I am, I'll demonstrate that when I get into the API gateway. I'd say the predominant outcome of a Lambda function is in fact calling other services. The actual result part, it's useful for the REST APIs that I'm going to talk about and for talking to mobile devices, but it also has some limits. So most of the time you're writing to a database or queuing something up or calling a service in response to an event. And here we go. And one other point, my computer's here, and the projector doesn't see it. It's taking its time. Maybe I'll change that. Okay. Take that. There. So So last point I want to make about events is that a function, a Lambda function, is designed to respond to only one kind of event. You can't write a function, at least not. It's not within the spirit of Lambda. You can probably kludge something together, but the philosophy is you design a function to respond to exactly, well, at least of the first 7, one of the first 7. You may be able to define a function that responds to either Android or iOS, that responds either to a mobile app or a REST call. But these first 7, if you're responding to Kinesis events, then that's all you're going to do. If you also need to respond to DynamoDB events, you write a different function. You can't write one function that responds to the 2 of them. So one of the more interesting applications, sorry, we're 10:45?
Yes.
Okay. That's just about it. One of the more interesting applications that was just recently released by Amazon or services, combinations of services, is using what they call their API gateway service to define a REST interface. So this is a 2-part thing. You define your function in Lambda, and it's the function that's called. And then you define an externally visible REST interface through the API gateway and plug it into Lambda. And now functions can make REST calls to your Lambda service and get the result back. Once again, it's serverless, and although it may seem, the benefits may seem modest, there's actually a lot of management being done here by Amazon on your behalf. It does relieve a lot of that hassle. So the way this works, it's 2 steps. You define a REST gateway. So first you define your interface as you would with any REST system. What are the resources, what are the methods? And I'll give an example of this in a moment. What are the parameters, the status codes, the return types? So you define all that in a semi-usable notation that Amazon has borrowed. And then you link that external interface to to a backend. The backend could be an existing application if you've already got one. In our case, we're going to link it to a Lambda function that we just wrote, the hello world function. So you map the incoming request that came in with the REST to whatever format your backend needs, and then you map the reverse direction. The result that's returned by your backend gets mapped back to whatever external format the result, the REST interface provides. And then you can define authorization checks of various sorts on the REST interface, if you wish, if you don't want it to be available to everyone. Having defined it, you deploy it. And deploying, this is again another one of these serverless options. It's really simple. You say, what's the maximum call rate? And there's also a burst rate you can exceed briefly. And then you just say, deploy that sucker. Again, you're not thinking about instances, load balancers, scaling. You say, here's my REST interface, run it. And I'll accept 500 calls an hour, or whatever the rate is. So what are some of the management things that this service does for you that are at least awkward, if not downright painful? Handles all the provisioning. Again, you're not thinking of containers and instances. If you wish to use Amazon's IAM identity signatures on the REST call, again, this is not necessarily something the external user would see, but so that the client software uses Amazon signatures, the Amazon gateway will decode all that stuff for you, and that's really nice. As Dennis was saying, cryptography, not something mortals really want to get involved in. It handles all the conversions. It links whatever instances the REST endpoint is running on to the instances running the Lambda code, does all the load balancing, and it has some at least machine-oriented and maybe human-guided services or behind-the-scenes algorithms that are looking for denial of service attempts and mitigating them. So it can actually handle some of the awkwardness of potential attacks. Okay, so here's how we're going to create an API. I've got a couple here. Create an API. New one. I'm going to call this a name. It's a lot of, well, whatever. Too many capitals in a row. And that's it. Start. So here's currently our interface doesn't actually support any calls to any resources. Although that's simple to add. We'll create a resource, which I will call hello, and the path to that is /hello lowercase. And now I need to provide a method on that resource. Since we're going to be sending a JSON request, I'll use a post method. You can use API Gateway for as a front end to a multitude of different services, not just Lambda. We're going to use Lambda. Here's the region. So I'm defining everything in US West 2. I'm a graduate of Oregon, so I like to support Oregon data centers. And this is the one nasty thing. I have to remember the first letter of my function. It'll autocorrect, autocomplete. Anyone, did I call it hello world? Agile? Hello Agile. Oh, that's actually not even the first letter. Smart. So that's the name of the Lambda function I define. This is the user visible name, not the actual name in the Python code. So the nice thing about this interface is that it shows visually how this process works. A request comes in. First, you define the parameters of the request. Then you define how to map the external form of the request to whatever you're going to pass to Lambda. That gets passed on to the Lambda function. Arrow. The Lambda function executes, returns a result. This defines how to interpret error codes from successful codes and the resulting HTTP status results. It also defines how you're going to map the representation used by the backend to the representation you define for the interface. And then this defines how that result is sent out to the outside world. So request comes in, processed by your backend, Lambda, returns a result, that gets mapped to whatever the ultimate client is going to see, and out it goes. Okay, let's try this. So let's run a test. So at this point, just to see if our API works, and again, we'll try so again, our simple hello world only takes an object or request with 3 keys in it called P1, P2, P3, and then an OK. And it's doing online syntax checking of the JSON there. So you can tell me the line where there's a problem. Okay, let's run that test. So we're going to send this object as an HTTP post request. It'll get, we haven't defined any mappings, so this value is just going to go straight to the Lambda function. If you recall, the Lambda function just makes sure that there's an OK key, and then it returns the value associated with key 1 as the result. Let's see if it all worked. Unfortunately, due to scrolling, what happened? Oh, there we are. Sorry. So the request was made, the status was 200, the latency was 56 milliseconds, and sure enough, the response body was the value of key 1. So the JSON object payload was passed to Lambda, the function ran, printed a bunch of stuff in the log, we'll see that in a moment, and then it returned the value associated with key 1 as the result, and that got returned in turn as a result of the REST call. And then for debugging, as you work with AWS and probably the counterparts at Microsoft and Google, you become, I don't know if it's used to or just inured to very long, complicated log messages. I don't think we'll ever get away from the equivalent of hex dumps, even after 50 years. It isn't in hex, but it's not much better than that. With practice, you can learn this stuff, and it actually starts to make sense, and it's useful for debugging. Yeah, what are we doing here for time? Okay, 4 minutes. So we could also, I was going to initiate an error request by giving an incorrect payload, but I'm not going to do that because we only got 4 minutes and I want to talk a little bit more. So, to summarize then, the beauty of this is you define a Lambda function, takes an event, does something, returns a result optionally, and then it's just called automatically whenever those events occur. If you want to export that function to the world, you just define one of these REST gateways. It takes a little bit of experience to get used to it, but once you've done that, it's perhaps not straightforward, but reasonable. You can get it done with practice. And again, you never need to worry about how many servers you're running or how many containers you're running. So, what are the catches to this? There's two issues, or two classes of issues. The first is just restrictions on what you can define and not define. You're limited in the choice of runtimes that you can run, as I said. And underneath it all, there's one specific Linux kernel release. So that most affects you if you're running libraries that are compiled in native mode. They have to be compiled against Linux kernel 4.1.19-24-31 to work correctly. There's also only limited ways to specify computational power. So, as I said, you only get to pick memory size, and then the size of the CPU is derived. And I don't believe Amazon has ever published how this corresponds to CPU power. You just sort of know. Bigger memory means bigger, more cores, I don't know. You can't use GPUs. So if you've got an algorithm that really sings on a GPU, at the moment Lambda is not for you. You have to explicitly deploy the function in every region, as I mentioned earlier. I'm going to skip 4 because that's a whole other slide. Startup time can be bimodal. And the last are some smaller points. Because the invocations of the functions are completely controlled by the Lambda runtime, trying to coordinate across them is probably a fool's errand. This kind of architecture works best when each event is just handled independently. There may be high-level aggregations, you're computing net statistics, but you don't want to coordinate between independent invocations. It's just going to resist you. Another thing that I'm not sure how much of a problem this is, I think it could be, most organizations with at least extensive online services, they do progressive rollout rather than just saying, here you are, everybody, new feature, let's hope it works for you all. They usually do give to 10%, 20%, 30% progressive rollout. They have canary instances where they release it to a few users and they see if the system crashes. That isn't supported with Lambda in any, at least not in the native mode. You might be able to build your own infrastructure, but it would be a little awkward. Beyond, you can roll out a region at a time, but within a region it's just all or nothing. The users all get it, or they don't. Final point is, no matter what your native language is, if you're going to work with Lambda, it does help to be able to read Node.js, because a lot of the examples and blog posts out there are written in Node. So if you want to find out how to do something, there's a high chance that someone has done it in Node and not necessarily in Java and Python. And the last point, okay, 30 seconds. The last point is that startup costs can be difficult. So that's going to your question. I said you never have to think of instances, but that's a lie. There's one case where you do have to think about instances, and that is when a container starts up, typically it has to do a whole bunch of things. You have to boot the container, obviously. You have to start the runtime environment for your application, Node, JVM, Python. Then specific to your application, you have to load libraries, you have to initialize globals, yada, yada, yada. Depending upon how much of that stuff you do, it could be expensive or not. And the problem is you pay this cost every time a container starts up. And you have no control over when the container starts up. That's the advantage of using Lambda. It's also, in this case, a weakness. You've turned everything over to Amazon, now you've lost control. So is a given instance, is a given call to your Lambda function going to pay the startup cost? Maybe, maybe not. since I'm running late, I won't. They do try to mitigate it. They keep a pool of warm containers around that they reuse if they can, but you can never guarantee that they'll be there. So I'll just end with this suggestion. I wouldn't get paranoid about startup costs necessarily. First, just decide if this architecture works for you. And maybe if you're just getting into this, start by writing some low throughput application, not necessarily mission critical, get your feet wet, get used to it. And if the structure of the Lambda structure fits for you and you don't need a lot of initialization, do it. Remember that although you may be spending extra money for the startup costs, you're saving money and that you're never going to be over provisioned. You only invoke a container or an instance when there's an event that requires it. And lastly, if your structure of your application might be amenable to this, but you suspect you have some sort of heavyweight initialization for your app, you probably want to run some sample tests and check things out and see ways of mitigating it. And in the end, Lambda may not be for you if you're doing some really expensive startup cost at the beginning of whenever the container is initiated. A lot of apps, that's not going to be an issue, so I think the model fits one. So, we're running out of time here. I'll be around for lunch and after, so happy to take other questions, but I think I'm going to end the talk now. And thank you again for your attention, and thanks to the organizers for all their help.